Alright, we're going to try this one more time. In this lesson, we're going to find the procedure to find percent composition. And so I want you to pay attention to this term, percent, which is basically, finding percentages like you've always done in math, for example. So it is always going to be part over whole times 100. Okay, so that's how you find percentage. So it doesn't matter if it's for chemical compounds or for like your grade. The formula is always the same. It's part divided by whole times 100. Alright, so these are the steps to find percent composition. Step number 1, you are going to find the molar mass. Okay, we've already learned how to do this. For this, you have to have the correct formula. You will also need your periodic table, so have that handy. You will find the mass of individual elements by looking at the formula, again from the periodic table. Then you're going to do step number 2, which is this one, divided by step number 1, which is that one, and you're going to multiply it by 100. Now you will go to repeat step number 1, 2, and 3 for each element. So for example, if your formula has 5 different elements, you will have 5 different percentages, and for each of those 5 elements you will have to do step number 1, 2, and 3. Okay, so we're going to learn this concept by using some examples. We're going to start simple, and we're going to go with H2O. So H2O, water, has 2 hydrogens and 1 oxygen. So you will need your periodic table, and you will learn that from the periodic table your mass of oxygen is 15.999 and the mass of hydrogen is 1.008, but you have 2 hydrogens, so you will multiply it by 2. And obviously this stays as 15.999, but this one is 2.016 plus 15.999 should give you 18.015. Okay, so now that you have this much information, we're going to go ahead and find percentages. So first you're going to find percentage of hydrogen, which should be, remember, it's part over whole. So this is part and this is whole. And so you get 2.016 divided by 18.015 times 100. After doing the calculation, you should have gotten 11.19%. So we're going to do the same set of calculations, but this time we're going to do these for oxygen. So percent oxygen would be equal to 15.999 divided by 18.015 times 100, which should give you 88.81%. Now here's how you check your answers. This is the percentage of oxygen, right? This is percentage of oxygen, and this number is the percentage of hydrogen. If you were to add this figure and this figure, they will equal to 100%, which makes sense because your percentages always add up to 100. Now sometimes they will not. Sometimes they will equal to 99.9 something, and sometimes you will get an answer that's 100.0 something, and that's perfectly fine because we round in chemistry, and so when you round, then your answers are not going to match up exactly. So but as long as you don't get like 95% or 97% or 103%, then you should be good. Right, second example, take a note that I mistyped the formula for calcium phosphate. So make sure you make note of that. Now you're going to find the molar mass using the periodic table. So pause the video and go ahead and find the molar mass. Alright, so the molar mass you should have gotten is 310.174. Now I went ahead and put the masses of calcium, phosphorus, and oxygen, and I multiplied them by their respective subscripts. So I have 3 for calcium, which is where I get that from. I have 2 for phosphorus because this 2 multiplies the phosphorus, and I have 8 for oxygen because again this 2 multiply this 4, and so that's how you get 8. So go ahead, pause the video and work it out. And these are the 3 masses you should have gotten for calcium, phosphorus, and oxygen. Now we're going to use these 3 masses to find the percentage of each of the 3 elements. So remember, in this problem you're going to have 3 different answers. 1 answer for calcium, 1 answer for phosphorus, and 1 answer for oxygen. So let's do the first one, which is percentage of calcium, which would be 120.234 divided by 310.174 multiplied by 100, and you can go ahead and do the math. Similarly, for phosphorus, you will have percentage phosphorus, which is going to give you 61.948 divided by 310.174 multiplied by 100. I want you to make a note of this thing, that your denominator is always going to be the same. See, it is the same every time, right? So when you do the calculations for percentage of oxygen, okay, your denominator is still going to be 310.174, and your numerator is going to be this number, which will go right there. Okay, and because it is percentage, you will find you multiply by 100. Alright, so after doing all your percentage calculations, this is your answer number 1, answer number 2, and answer number 3. What I need you to do is pause the video, go ahead and add these 3, and see if the answer you get is approximately 100%. My guess is it will be. Now our next problem is slightly different. It's still asking you for a percentage, okay, percentage of hydrogen, but this time it gave you a specific amount of H2SO4, which if you watched the previous video you will know it is sulfuric acid. So what do we do in this case? Your initial steps are going to be exactly the same. So what I want you to do is I want you to do 3 things. I want you to find the molar mass, which I'm going to abbreviate as mm, and then I want you to find the mass of H. Alright, so this is what you should have gotten. You should have gotten the molar mass as 98.078, and the mass of hydrogen should be 2.016 because there is 2 hydrogen atoms. Now you're going to proceed just like you did, which is you're going to find the percentage of hydrogen, which is going to be part over whole. So 2.016 divided by 98.078 times 100, and I'll let you pause and do the math. So the answer you should have gotten is 2.06%. Now let's quickly talk about what this really means. It means that if you have 100 grams of sulfuric acid, which is H2SO4, then it will have 2.06 grams of hydrogen. This is what it means. So out of 100 grams of this chemical, 2.06 grams will be hydrogen. So if 100 grams have 2.06, then 65 grams will be, let's say, X grams of H. And so now all you need to do is do a simple proportionality, or you have to find the value of X basically. So we'll set this up as a fraction. Alright, so apparently I forgot to hit record. So this is what I have done. I have set up the proportionality, which is 100 grams give me 2.06. Therefore 65 grams will give me X. And then I set up the proportion as fractions, and then I cross multiply and divide to find the value of X. And this X will be the final answer to our problem. So go ahead and pause the video and see what you get. And the answer you should have gotten is 2.06% again. And so be prepared to discuss in class, why do you think that is? Why did we get the same answer again? And what are the reasons behind that? So let's move on to the next problem. So for this last problem, I have taken the example of glucose, which is this molecule C6H12O6, and that means that it has 6 carbons, 12 hydrogens, and 6 oxygens. So by now you should know the drill. We have the formula. We're going to find its molar mass, and our molar mass for this particular chemical is 180.156. Okay, so 180.156 is our molar mass. Now you're going to similarly find the mass of the 3 elements. So what is the mass of C, what is the mass of H, and what is the mass of O? Remember that you have a subscript for each of the 3 elements, so whatever mass you get for each, you will multiply by the subscript. So C will be 6 times the mass, H will be 12 times the mass, and O will be again 6 times the mass. We know C is 12.011, H is 1.008, and oxygen is 15.999. Okay, so go ahead, pause the video, and figure these answers out. After performing the 3 multiplications, you should have gotten these 3 answers: 72.066, 12.096, and 95.994 for carbon, hydrogen, and oxygen respectively. Now you gotta remember the process, which is we're going to find 3 different percentages. So you will have percentage of carbon, percentage of hydrogen, and percentage of oxygen. So this would be a good time for you to kind of evaluate if you have understood the process. So what I want you to do is I want you to pause the video. I want you to figure out all 3 answers, and then I want you to hit play and check your answers. Alright, hopefully the 3 answer you got was 40% for carbon, 6.71% for hydrogen, and 53.28% for oxygen. You want to quickly do a check to see if you get the right answers. You add them up and see if they add up to 100 or close to 100. Alright, now to the last step of this problem. You have to find the percentage of carbon in 35 grams of glucose. So I'm going to set up the process for carbon, and then you will have to do the process for hydrogen and oxygen. And when you come to class tomorrow, we will kind of check your answers and answer any other questions you might have. So let's see how it's done for carbon. You have 40 grams carbon and 100 grams. So X grams of carbon in 35. Remember, it's a proportionality. So we're going to set up a simple fraction, which is going to be 40 over 100 equals X over 35. I apologize for the squeaking sounds. And you will cross multiply and divide. And so X would be equal to 35 times 40 divided by 100, which I'll pause the video and let you guys figure this out. So the answer you will get is 14 grams. Now remember, you still need to find percentage, so move this over a little bit. You have 14 grams of carbon in 35 grams of C6H12O6. So if you're to find percentage, you will do 14 divided by 35 times 100, and go ahead and hit pause and find the answer again. And the answer you should have gotten is 40%, which is basically the same thing as you had gotten in the first place. So to verify, here's your 40% of carbon, and here's also 40% of carbon. So it really doesn't matter if you have 100 grams or 35 grams or 40 grams or 5,000 grams. Your percentage of each element in any given chemical is going to be the same. Now why that is, we will discuss in class. So I did the process for carbon. I want you to solve for hydrogen and oxygen, and remember, you have to show work. I will look for it in class. Okay, so make sure you get this done, and I will see you in class.